This is the Topic 3 Cycle 1 homework video for physics class, and we're focusing on momentum and impulse. Momentum, we're going to use the letter P to stand for momentum because M is already taken for mass. Momentum has a direct relationship with mass, M, and velocity V, meaning as mass goes up, a more massive object with the same velocity has more momentum. And on the other hand, a object with more velocity and the same mass has more momentum. So as velocity goes up, momentum goes up. As mass goes up, momentum goes up. That's a direct relationship. Since velocity is a vector quantity, that means the direction that the velocity is in matters. Momentum is also a vector quantity. When we don't have the little vector sign, we use a bold abbreviation to show that here. That means if we're going to go with a simplified example that an 80 kilogram runner running right with 2 meters per second of velocity has 160 kilogram meters per second of momentum. Whereas a runner going left, we'll consider that negative 2 meters per second of velocity, would be negative 160 kilogram meters per second of momentum because it's a vector quantity. Our units are not clean for momentum. They're just mass has the unit kilogram, velocity in meters per second. So our unit that we're using is kilogram meters per second. Momentum is a conserved quantity, meaning if one object loses momentum due to a collision, the second object in the force pair gains that momentum. So the momentum isn't just lost. We're going to be talking a lot about conserved quantities now and as we move into energy in our next topic. Now we're going to look at change in momentum. Change in momentum we call impulse. We use the letter J to stand for impulse. I is already taken for current and electricity, which we'll look at later in the year. So impulse is the change in momentum, is the best way to think about what impulse is. So it's a force exerted over time. So here we have impulse equals force times time. That means impulse has a direct relationship with both force and time. As the force exerted on an object goes up, so does the impulse. As the time that that force is exerted goes up, so does the impulse. Which makes sense. If you're pushing an object with the same force longer, you're imparting more momentum to it, also giving more energy to it. So one way that we express this is that J, which is impulse, equals delta P. The delta, the triangle there, stands for a change in momentum. So the impulse is the change in momentum. When we have the symbols down here, P sub F, that stands for the final momentum. So the final momentum equals the initial momentum plus the impulse. We could also solve for that and just say that the impulse is the change in momentum. Another way to look at it. So think to our water balloons today. When an object came to a stop, as with our water balloon experiment, it loses all of its momentum. I want to know the net force on that balloon. So I want to solve this equation for impulse in terms of force. So I would divide both sides by T, by the time. And I get that the force exerted equals J over T. And that means that the time that a collision takes has an inverse relationship with the net force felt. So if we're slowing an object down to a stop, then we know that impulse is going to stay the same. We're going to take all of its momentum away to zero. So that would stay the same. But the time, we can extend the time of the collision by like catching it and bringing it towards your body, would reduce the net force the balloon experiences. On the other hand, if we just kept our hand flat for the shortest collision possible, it's going to experience a lot of net force immediately, or a lot of negative acceleration. So as the time of the collision is greater, the net force the object experiences is less. So we could also look at this in terms of our acceleration formulas. Here, acceleration equals the change in velocity over time. As time goes up, that acceleration goes down. We also know acceleration equals the net force over the mass. The mass of the balloon stays the same when we're throwing it. If we have a lower acceleration, because we took more time to catch it, then that means we're minimizing the net force experienced by that balloon. So just basing it on the formulas and what we've already gone over. So the key idea here is that as time goes up, the net force of the impact goes down, an inverse relationship. So for our multiple choice question, we're going to be looking at our student right here, picture doing the water balloon experiment. When she catches the balloon, she decides to allow her hands to follow the motion of the balloon, extending the time the balloon slows down. She does that because, pause here to look at the answer choices A, B, C, D, and E, and answer the multiple choice, and then please restart the video to get your free response question. So in your free response question, I would like you to use the word impulse, and momentum, and describe how the time that a collision lasts affects the amount of net force the object feels in terms of its impulse j. This should be a simple two-sentence answer, just describing net force and their relationship. Think about whether it's a direct relationship or an inverse relationship between time and net force. Feel free to go back in the video and take a look, then answer the free response. Please also think about how you might apply what we've learned here to your egg drop in order to keep that egg safe.